Hello students. Today we need to understand the first module in microcontroller. Just I'll give the introduction on this subject. We came to know the basic concept of a processor. With respect to that, we need to know the difference between microcontroller and microprocessor. And later stages, what are the application of microcontroller, where all we are using the microcontroller. Then we are going to understanding about pin description of 8051 microcontroller. With that, we understanding about the architectural part, different types of architectural part, and then we understanding the 8051 block diagram as well as architectural function unit. So let's see each one by one 8051 microcontroller subject in the first module. So microprocessor based system, it consists of CPU, external RAM, ROM, IO devices. Remember, the microprocessor does not have the internal RAM, ROM, IO ports in the CPU. We need to connect it to the externally. So this is the block diagram for the microprocessor based system. Example, we have 8085, 8086 microprocessor. So general purpose microprocessor, it has having data bus and address bus. Externally we connect it to the RAM, ROM, IO ports, timer or serial ports. This is general purpose microprocessor system. Come to the microcontroller, a smaller computer on a chip. It has on-chip RAM, ROM, IO ports, timer, serial controller. Example, we have 8051, Atmel 32, Motorola 6811. These are the microcontroller. Basically, evolution of microcontroller with 8-bit, 16-bit and 32-bit microcontroller. So this is the functional diagram for the microcontroller. See, all the RAM, ROM, serial communication port, timers, IO ports are embedded in a single chip. We'll see the difference between microprocessor versus microcontroller. See, as we know that microprocessor, it has only the CPU, other additional peripheral, it is externally connected. It means that it doesn't have the RAM, ROM, IO ports. So microcontroller, it's all embedded in a single chip. So remember, for the microprocessor design, can design it on the amount of how much memory is required, or a ROM or ROM, as well as the IO ports, because how many peripheral you want to connect it to the microprocessor, so that many memory as well as the IO ports are required, so that we have the more peripheral we need to interface to the microprocessor. It is so expansive and it has a versatility, and it should be used for any purpose. We can't restrict to a single application, but it is very expensive. You come to the microcontroller, all CPU inside RAM, ROM, IO ports, timers are all embedded in a single chip. So everything is in inside. So fixed amount of on-chip ROM, RAM, IO ports. It is fixed. Let's say in 8051, RAM is 128 bytes and ROM is 64 kilobytes. And similarly, we have the 4 IO ports, each port having 8 bits. So that means that it is fixed. So with respect to that fixed amount of the memory as well as the IO ports, we can we can use the application in such a way that the availability of memory as well as the ports. So everything is in inside. It is not expansive, so that it can be a single purpose, and we have the special purpose also. So these are the basic difference between microprocessor and microcontroller. Other than that, we have some more uh, difference. We can see that one by one. Let's say firstly we have the microprocessor. And this is your microcontroller. First difference, we can see that in microprocessor, large number of instructions with flexible addressing mode. But here limited number of instruction with few addressing mode. So as we know that it is very flexible designing aspects in the microprocessor. This is in addition to the circuit, it is very flexible. So we have few bit handling instructions. Let's say AND, or not. This many things we can see in the microprocessor. Here we can see that more bit handling instructions along with all logical instruction. As well, we have the left shift, right shift, we can have the bit set, we have the clear bit. So like that we have so many bit handling instructions present in microcontroller rather than the microprocessor. As comes to the pin description, here we can see that less number of multifunctional pin, here we have more number multifunctional pin. So if you have the more number of multifunctions, so that it will be uh, works with more applications. So these are the other differences with the microprocessor and microcontroller. Microcontroller based embedded systems. So it is a special purpose computer system. It usually everything is available in a single device for control all the peripherals. And also it has specific requirements and perform predefined tasks. We'll see some of the examples in embedded system design. We have the cost reduction compared to general purpose processor. Different design criteria like performance, reliability, availability and safety. These performances we are supposed to check to design your embedded system. Let's say we have the different embedded system examples. This is the one example. We have smartphone, camera, game machine. We can use in the tablets, televisions, industry, biomedical, printer, car, phones. These are we can see. Let's see one by one examples. Ultrasonic range. This is the sensor we can use to find the distance between the object so that it can be measured the distance and display in a LCD, where we can use this to find the obstacle in automotive electronics or in the robotics or in water level indications. So wherever we have to find the distance, we can find out, we can use this embedded system design. And we have the water level indicator. See here we have the floating sensor. This is digital sensor. This finds the whenever the floating sensor it is floated to the on mode or off mode. So when the float sensor it is contacted, then it will be on. It means that there is no water. If the water is present, the float level it is increased, then it is off mode, so that we can program to indicate your water level. Next we have the solar panel or sun tracker. See here we can use one stepper motor and as well as the LDR, light detector resistor. We keep the LDR on the solar panel with respective to the range or the distance. It finds the light intensity of the solar or the sunlight. So whichever the, probably we are using the LDR, light detector resistor. So sunlight, it fed on to the LDR, it gives the voltage level high or 0. With respect to that, we can rotate the stepper motor. Next we have the RFID based access control system using 8051. Probably we can use this for security system, RFID tags, like we can implement in the school, colleges, offices as a ID cards. Nowadays we can use these things in the automobile also for security reasons or toll plaza collections. Normally this RFID reader, it is receiver and the transmitter we have. It operates on 125 kilohertz frequency. Next we have the part of architectural view. See, as we know that microprocessor or microcontroller as designed in such a way that are fabricated in such a way that some of the architectural view. So we'll see that there is a two different architectural view. One, we have the Harvard architecture, and one more we have the Van Neumann or Princeton architecture. So it comes to the Harvard architecture. In Harvard architecture, there is a separate program memory as well as the data memory. We can see that this is your microcontroller as a CPU, as we telling that, and this is your program memory and this is your data memory. We have separate address bus and instruction bus for the program as well as the data, so that we can access the instructions or the data, whatever we return the instruction in the program memory as well as the data. Simultaneously we can fetch or modify for the different buses. This increases the execution because it takes the less machine cycles. Normally this is used in RISC processor, reduced instruction set computer architecture we are using. This is also known as data flow or data driven computer. This is also known as data flow or data driven computer. So we have a separate program memory as well as the data memory. For design, it takes complex. It is for the design, it is complex. So that examples for this, we can use any microcontroller like 8051 as well as special DSP processor, are all in the hardware architecture. So the advantages: speed up of the data transfer rate, permit the designer to implement different bus width and word size for program and data memory space. Von Neumann architecture or Princeton architecture. So Von Neumann architecture, or also we call it as Princeton architecture. We have the CPU, So we have the program memory, we have the data memory, it is embedded in a single area so that I can access data as well as the code only one at a time, because with address bus, through that I can access the data or the program. So I can say that here it is a single memory space. It is not possible to fetch instruction, code and data at the same time. Normally it is used in CISC processor, instruction set computer. This is also known as control flow driven computer, as we know that hardware architecture is data driven computer. Example 8085, 8086, etc. So these are the main difference between hardware and one human architecture. Let's stop here to know what all the things we discussed. We understand about what is microprocessor and microcontroller, the difference and application of microcontroller. With that we can come to know that what is embedded system design and how this microcontroller is applicable. Few examples we explained, and also the fabrication, the design architecture is in two parts. One is one human as well as another one in hardware architecture. We explained about hardware architecture as well as the one human with the differences. So thank you very much.